Hey guys, this is Eric Miller. I'm at M&M 2024 in Cleveland, Ohio. We're at the mega booth with Torsten and Peter from Raith Technologies. And last year we talked about this really, I thought it was completely insane, a triple ion FIB source. It was just crazy, but it was really fascinating. So tell us about that technology and what it is that you've done with it since last year.
So last year we were talking about this ion source technology and talked about a few use cases. This year we have merged different technology bricks and components and made a system out of it. And the system uses this liquid metal alloy ion source technology, so we call it Ion Select, and we use a magnetic sector SIMS unit for analysis on the system. So this is what we did in the last year.
Okay. So Peter, tell us about the new instrument that you guys have here at the show.
So I'm here to promote our new tool, the IonMaster, that we're launching during the show, during this M&M. And this is a high-resolution analytical ion microscope. It's designed for highest resolution ion beam imaging. And at the same time, we can do highest resolution SIMS analysis on samples, nanoanalytics, and we can cover the whole periodic table, all the isotopes there.
So yeah, I understand the benefit of an ion microscope is that the ions travel at smaller wavelengths or shorter wavelengths or whatever, smaller/shorter wavelengths than electrons do. And so even though the ions are much larger, you can get better spatial resolution in an SEM type thing. Is that correct? Or am I making things up?
It's both. It depends actually on the source technology that you're using. So for the helium ion microscope, the wavelength was important because the source had a super high brightness and was very small. We're using a source that's a little bit bigger. It's like a liquid metal ion source. It's an alloy ion source. That means we do not achieve the full brightness of the helium beam, but we can achieve resolutions in the range of 1.5 nanometer, which is very good still. And if we look at the analytical spot size, we're same as for the helium ion microscope, in the range of 50 nanometers.
So it's a very versatile tool. So you can use it, as Peter mentioned, for ion imaging. And ion imaging has big advantages compared to electron imaging. So you can use ion beams for samples which charge up. So you can apply a flood gun in order to get rid of the charging. So that's very smart. So you don't have to coat the samples if you do ion imaging. I want to add that we have got a very fancy stage technology in our system as well. So the entire nanofabrication capabilities are maintained as well. So that's quite amazing. And there's also a big advantage for SIMS analytics because we can load CLAR files, can navigate on these CLAR files, we can do this cut navigation, we can precisely navigate the region of interest to the beam, to the analytical spot, and perform analytics on pristine sample surfaces without damaging the samples. And if it comes to analytics, we have got options regarding the primary ion beam. So we can use light ions like lithium, which is a very reactive ion, but we can also use heavy ions like bismuth or gold, depending on the source that you're going to use. And you can adapt the application according to your needs. So that's quite fancy.
We have full nanofabrication capabilities with the different ion species. So it's a full nanofabrication tool with a laser interferometer stage for large area, stitching-free nanopatterning, which I think is very unique.
Wow. Yeah. Okay. So if people are interested in learning more about your instruments, where do they find you?
Yeah, on our website, raith.com.
Raith.com. Okay.
Raith.com.
So check out the Master of Ions, Torsten, at Raith.com. Okay, we'll talk to you guys again next year probably, and we'll see you in the next video. Thanks.